Hey guys, welcome back to my CCNA 20301 course. Patrice is here, and in this video I'll be talking about VLAN. Are you ready? Let's get started. Virtualization technology has changed our lives by all means. One of the use cases among many is VLANs or virtual LANs. VLANs are simply help us to break a physical switch into multiple logical switches, so we can separate different sources of network traffic. For example, for different departments of our company, or to separate sensitive service data from the client machine's data, etc. So as you can see in the slide, when we define VLANs, we assign physical interfaces to each VLAN. And in this way, ports 1 and 2 now can talk to each other only, and ports 3 and 4 can talk to each other only, but not port 1 to port 3 directly and vice versa. Therefore, VLAN concept helped us to make two logical or virtual switches in a single physical switch. VLANs have many advantages, including they will create a small broadcast domains which will increase the performance of the network. When we separate different traffic through VLAN, we have the opportunity to manage the traffic flow between them through ACLs or access control lists, which I will talk about them later in this course. VLANs help us to separate our sensitive data from the rest of the network. And finally, they will generate less workload for spanning tree protocol or STP, another topic in the switching which I will talk about it later in this course. To be able to identify each VLAN uniquely, each VLAN must have an ID. This VLAN ID is a 12-bit value, so the values could be from 0 to 4095. VLAN IDs 0 and 4095 are reserved for system usage. So the range we can use is from 1 to 4094. This range is divided into two groups. VLANs 1 through 1005 are called normal range, and VLANs 1006 to 4094 are called extended range. Basically, the extended range is designed for service providers to give them more flexibility and options for service delivery, but it doesn't mean you cannot use them in your networks. However, you have to consider a few things. First, normal range information is stored in a file called VLAN.dat, which exists on the flash memory. But extended range information is stored in the running config file. Also, VTP, which we'll talk about it later in this course, does not support extended range. Cisco switches have been designed in a way that even if you do not have any networking knowledge, you can simply open the box, physically install it, power it on, connect the computers or any other devices you have to it, and boom, it works. But how? There are many different default settings which make this approach possible. One of them is, by default, there is VLAN 1 on all switches, and all switch ports are in that VLAN by default, so they can communicate to each other. This default VLAN cannot be modified or deleted. Now let's assume that we have more than one switch. What would happen if we need to carry different VLANs traffic between the switches? One solution is having a separate connection between switches for each VLAN and send the according traffic over the desired interface, like the one that you can see here. There is one link for VLAN 2 and one link for VLAN 3 traffic. This method is not the one that we use it in the networks. Instead, we use the concept of trunking and VLAN tagging. With trunking, we select a connection between the switches and configure it as a trunk port. Trunk ports are able to carry the different VLANs traffic, but how? With trunking, the source switch simply tags the outgoing frame on the trunk port, so the destination switch can read this information and understand which VLAN that frame belongs to. To be able to tag the traffic, we need a protocol. Ages ago, Cisco invented a protocol called ISL. This protocol was not very productive, but was a great invention at the time and made the trunking possible. What ISL does is adding an extra header and trailer to the original Ethernet frame. The ISL header is 26 bytes and the trailer is 4 bytes. So ISL adds extra 30 bytes in total to each outgoing frame. Recently, Cisco removed the support of this protocol from its switches. Later, IEEE introduced a standard and more productive protocol called IEEE 802.1q, which often referred to as just .1q. How .1q helps us to tag? Simply by adding an extra 4 bytes header, which is inserted into Ethernet header right after the source MAC address field. This header includes type field, which is 2 bytes or 16 bits, and it has the value of 8100 hexadecimal, which means it is an Ethernet frame, priority, which is 3 bits, 1 bit for CFI, and 12 bits for VLAN ID. 802.1q also introduced the concept of native VLAN. Switches simply do not tag the native VLAN data, so if the destination switch receives a frame without a tag, it understands it belongs to the native VLAN. So both sides need to agree on the native VLAN ID. In the next video, we will get our hands dirty with some basic switch and VLAN configurations and also troubleshooting. I wish you enjoyed this video. See you in the next videos and thanks for watching.